Hello, everybody. Good morning. Welcome to Olga channel. This is Cindy, and today we are going to look at another topic on probability. All right, so please subscribe to the channel, like the video after watching, and share to a friend in need, and God will surely bless you. So today we are going to talk about probability. This is a topic that we've learned from primary school through to SHS and in the university. All right, so today I just want to talk about how to use the probability table, that's the standard normal distribution table, how to read from it to answer some probability questions. All right, so I'll share my screen, then we'll proceed. All right, so we'll be talking about standard probability distribution. As I said earlier, all right, so when we talk about probability, it's just how should I put it? It talks about uncertainty. See, sometimes in life, some of our decisions or certain decisions we make, we are not very sure that it's 100%. Probability is just assigning values to certain situations which we are not very sure of whether they will occur or they will not occur. So a probability of 0 means that event will not occur, but a probability of 1 means that event will occur. All right. So today I just want us to um look at how to read the probability table. So I'll use some questions, and then as we are going through the questions, we'll pinpoint some of the needed information. All right. So probability is between 0 and then 1. All right. So the sum of all probabilities within a particular sample space should give us 1. Okay. So when you find probability for certain events within the same sample space, and then when you add them up, it's not equal to 1, then it means there's something wrong with your answers. So the sum of all probabilities within a particular sample space should give us what? 1. So that's one thing that we should know. So let's say if I know, maybe I'm looking for probability that something will occur, or maybe probability that I'll get money tomorrow is 0.5. Then I should know the probability that I'll not get money tomorrow, it will be what? 1 minus 0.5, which is equal to 0.5, right? So if for probability, what makes it easy is that if you know one side of it, you'll be able to determine the other side of it, all right? Because it's equal to 1, and the sum of them should be equal to 1. So if I know one of the probabilities and I want to find the other side of it, I'll just subtract from what? 1, and I'll get it, right? All right. So I want us to look at some questions. So with normal distribution, so we'll take some questions and we'll look at how to read it with the table. All right. So the first question that I have here says, X is a normally distributed variable with mean U is equal to 30 and standard deviation is equal to 4. So when you talk about the mean of probability, sometimes you can say expected value. Okay. So let's say in another case, not in this scenario, we are asked to find the expected value of what? A particular event. It's just the sample space times the probability, or the sample space for that event times its probability. And expected value is the same as mean. But in this scenario, we'll be finding mean, and then standard deviation. So standard deviation is like the value by which, let's say, um the mean is, how should I put it? Standard deviation. I want to put it in a way that I will understand. So let's say the mean is 0, right? So how far a particular mean is from the original mean. So let me put it that way. So let's say we have I want to draw something. So let's say this is our mean, 0, right? So the standard deviation is telling us that how far, so let's say here is 5. So how far this 5 is from 0? Or let's say here is -5. So how far this -5 is from 0? So how far a particular figure is from the center? So we know from our basics that mean is a central tendency, let's say, calculation or figure, right? So it's something like in the middle. So how far certain figures are from the center? So that's the mean. Basically, that's what it means. Okay. So and we want to find probability that x is what less than 40. So that is our aim. I want to use the normal distribution table. All right. So let me write it here. The probability. So we are supposed to find probability that x is what less than 40. All right. So with the normal distribution table, it's telling us that okay, so sometimes there are some probabilities that we might not able to find them easily. But then we have the table that can help us to find them. Before you can use the table, you need to change the probability to suit the table's conditions. Okay. So what we can do first is there's a formula. So on the table, the values there are labeled Z. Okay. So they are labeled Z. Then the formula to use in order to get a value associated with that of the table is that Z is equal to, so small z is equal to the mean. So I don't have the mu on my laptop, so I use just U. All right. So the value minus the mean divided by the standard deviation. So I use X, but the standard deviations symbol is this, all right, is this one, not S, but I don't have that on my laptop, so I use S. Okay. So that's the formula to use, or if you want to use the normal distribution table, this is the formula. So you have to first translate the probability that you've been given into this form. Then you use the table to read. So that's the first step. If you want to use the normal distribution table, the first thing to do is translate this figure into a form and that is what that corresponds to a figure on the table. So let me show you how the table looks like. So this is a normal distribution table, right? So this is how the table looks like. This is the positive aspect and this is the negative aspect, all right? So you know that probability, we have positive side and we have negative side. When you add them up, you have to get one. All right, so the normal distribution curve, we have a normal distribution curve that looks like this. So the drawing will look kind of funny, but then take it like that. So let's say this is the middle, right? So the center is the mu, that's the mean, all right? So that's the center. So for a normal distribution, there is an assumption that since the mean is at the center, then all other central tendencies are equal. So let's say like median, mode, and mean, they are all the same, okay, for a normal distribution. So this is the curve for a normal distribution. All right. So the middle or the center is the mean. So this part plus this part should give us the whole area under the curve. So it's like you having a triangle. Then you are told that the area, the length here is 4 centimeters. So if we divide this side into two, it means that this side is 2, right? And then this side is also 2, right? So in the same way with the mean or the normal distribution, okay, the left hand side or the positive side is equal to the negative side. So it's symmetric about the mean. So if we turn it this way, this side is equal to this side, but just that this side is the negative side and this side is the positive side. So what the distribution table helps us to do is that Instead of having big figures, that will make it difficult for us to find a probability. The table is telling us that we should assume that this mean is what 0, the center is 0. So that's the assumption. So the center is, so whatever happens here is supposed to happen here. Sorry. So in order to get the figures at this side, that's what the standard deviation, that's where the standard deviation comes in. So how far the figures here are from the mean is the standard deviation. So let's say the standard deviation is 1. So for the standard, the normal distribution, the standard deviation is 1. So from here to here, we'll have 1. Then this side will be -1. But this is the negative side and this is the positive side. But then they are symmetric about the mean. So this side is equal to this side. But on the graph or on a graph, we know that this side is the negative side. So if here will be 2, right? Because from 0 to 1 is 1. Then you add 1. So the standard deviation here is 1. In some cases, you can have the mean to be, let's say, 40. Right? Then the standard deviation will be 5. So the next figure will be 45, not 41. So for the normal distribution, you use 0 for the mean and then 1 for the standard deviation. But when you are given a question that the mean is not 0 but 40, that's the actual figures, 40, then the standard deviation is not 1, but is what's in the question. So if they tell you that the standard deviation is 5, and it means from 40 to the right hand side will be 5. We add 5 to it, then you get 45. To the left hand side, you subtract 5, then you get what? 35. So that is how the standard deviation works. Okay. So let's look at our question. So the question says B is less, sorry, we should find a probability of X less than 40. So our first steps, let me use a new, all right. So our first step is that first we have to what? Convert. So let me write this. Okay. So first we have to convert this into a form that is what's in the table, right? So the table, this is the table. And then we see that the values here ranges from -39 to +39. So we don't have 40 on the normal distribution table. Okay, we don't have 40, but it ranges from -39 to, sorry, -3.9 to 3.9. So the standard, the formula, or yeah, the formula that I said earlier, that z is equal to the x. So the x is the value minus, or yeah, the x is the value, the subset of the main sample space. So here it is 40 minus the mean, all divided by the standard deviation. So from our question, we know that the mean is equal to, the mean is equal to 30 and the standard deviation is 4. So mean is 30 and then standard deviation is equal to 4. So you just substitute these figures into the formula. So we have our z be equal to 40 minus 30, all divided by 4. So using our calculator, we get I'm coming. Okay, so using our calculator, we get 2.5, right? So 2.5. So this is the z value that we are going to use from on the table, the distribution table. That's the 2.5. All right. So we find out that we got a positive figure. So we use the positive table. Okay. But first, before we use the positive table, someone will get confused. If I get 2.5, how would I know that it is less than or equal to 40. So we have to first draw what the normal distribution curve, okay, so that you not get confused. So that will even guide you to know where or which direction the question is asking you to move in. So let's say, sorry, eh, all right. So this is our mean. So we know that on the normal distribution table, using that table, our mean is what? 0. So here is 0, right? So the figure that we get for our standard deviation, here is 4, right? But because we are using the normal distribution table, we will not write 0 plus 4 to get a 4 here. But instead, we have to look for a number which is equivalent to this 4. Just as this 0 is equivalent to this 30, there's supposed to be a number equivalent to this 4. And that is what the z. Okay, so now the z here becomes the new standard deviation. So that's this 2.5. So here we will have the z, which is what? 2.5. Right? And we know that from our table, this 0 is equivalent to 30, right? So let's say we write our 30 here. And this x is equivalent to this 2.5 here. So here will be 40. Right? So here will be 40. So the question says we should find a probability that x is what? Less than 40. Let's say our 40 is here. So less than means anything below this side, right? So probability that is 40. So anything within this range, right? So when you look at our distribution table, all right, so look at our distribution table, realize that so this one is shading this space, meaning that it's the negative table, right? So okay, so this table is for the negatives. When we look at the positives, this is how it looks like. So this table is for the positive, and we find the same expression in the curve we drew here. So we are here, and then we are looking for the figures within this range. So and the figure we got here is also a positive. So we are in the positive table. Okay. So what this is telling us that how do we read? Okay, now we've gotten 2.5 for the z, but we've seen some 0.000 here. So how do we read? So first, your 2.5, just add an additional 0 here. Just make it 2 decimal place. But let's say in the question you get something like 2.33. So let's say so let's say in the question you get something like 2.33. We don't need to bring another 0. So we always want 2 decimal place figure, right? Okay. So since it's just 2.5, all we have to do is what? Add a 0 to it. So how do we read? So first, on the z side, that's from the distribution table, we first read these two figures first. So we read the 2.5 first. So when you take 2.5, what we how should I put it? What will be the remainder? So let's say we have 0.00. Okay. So when you add this to this, we see that we still get 2.50, right? So what we want or what we are seeking at this point is that you first read the 2.5 first from the table. You look for it on the table, 2.5. Then you look for what? 0.00 or 0.00. So the 0.00 is after the decimal place. Okay. So we go to the distribution table, the positive side. Because when we shaded here, you see that it's at the positive side. So this is not included. And we get the same what? Table in the positive table, right? So look for 2.5. So here is 2.5. Where is it? 2.5. And then the remainders are what? 0.00, right? So 2.5. Then we look for 0.00. You get it? So this is the 0.00. So let me show it to you. So this is the 0.00. So when you add 2.5 to this one, realize that it's still the same 2.50. So we just add a 0 just to get this 0.00 here. Okay. So the 0.00 is the first column. So you first look for 2.5, which is this, right? Then 0.00, which is this. So the figure here is 0.99379, 0.99379, 0.99379, 0.99379. So this is the figure we got from our table, and that is our answer for the probability. So realize that it is what very, 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 very simple. You get it? Someone can leave it in percentages. That's 99.37%. Someone can leave it in this form. It is the same. So that's how we find the probability using our table. So first, we first write or fish out the information from the question. What is the mean? What is the standard deviation? After getting that, what is the question asking me to do? Find what x less than 40. But then we want to use the distribution table. Then the distribution table doesn't have 40. So but we have to convert the 40 to a number equivalent to the one that is on the distribution table. And we use the z formula, which is what x, that's the x, the value you are looking for, minus our mean divided by our standard deviation. The answer you get, if it is a positive figure, we use the what positive table. If it is a negative figure, we use a negative table. But sometimes you might not be given both tables, you might be given only one table. So that's where the issue comes in. You get it? Okay, so let's say this one, we got 2.5, but we're not giving the positive table, but we're giving the negative table. So this is how the negative table looks like. So this is the negative table. And then there's our question. Sorry. This we got 2.5, but then we have a positive table, a negative table. That shouldn't be a problem because we know from onset that probability, the sum of probability should give us 1. So if I know one side of the probability, I can find the other side. So if I know the positive side, and we said that the mean, that's the figures, they are symmetric about the mean. So this side is equivalent to this side, okay? So if here is 2.5 at the positive side, means if you want to get the negative and the probability sum up to 1, just subtract the figure we read from the table from 1. You get it, and we get our figure. So what I'm saying is, since it's 2.5, but we are using the negative table, so the same reading, okay, the same reading, but here we'll ignore the negative sign. I will look for 2.5. So what's 2.5? It is this, right? The 0.00, which was after the decimal point. So me, you are reading the 0.00621. 0.00621. So let me write it here. 0.00621. So this figure is not our answer because we read it from the negative table, but our answer we got was a positive. But we know that the probabilities are what symmetric about the mean. Okay, so if the probabilities are symmetric about the mean, means that if I know the negative side, then I can, but I don't know the positive side, I can use the negative to find the positive. So if I'm able to find the negative answer from the table, to find a positive is just 1 minus 0.00621, which is equal to, so use your calculator just to compare. 1 minus 0.00621, you got 0.99379. So that's it. So you see, we've gotten the same answer as the one we read from the what? The positive table. You get it? So you don't have the positive table, but you have the negative table. And then the z figure you got, the z figure you got was a positive. Just ignore the negative sign. Use the negative table to find it. When you are done, subtract from 1. That's all. Don't be confused. Just subtract from 1 because you are looking for a positive figure, but then you ended up on a negative table. As this probability sum up to 1, then I can use that 1 to get our positive answer. So look at another question. So look at another question. Says that P, or if you find a probability that X is greater than 21. So using the same mean and then standard deviation. So we go to our things, then it says we should find the probability that x is what greater than 21. We know that our mean is equal to 30, that our standard deviation is equal to 4. All right. So first, what you have to do is first is either ways you can first draw the curve, or you can first calculate it. So let me draw the curve. So let's say, so this is my mean, and the mean is 30, right? Then I'm asked to find 21, right? But 30 from 21 will be at the left of 30, not at the right. So it will be at this side, right? Okay, so this is the standard deviation. So from 4 units to the left of 30 will give us what? 26, right? Then another to the left to give us what? 22. And we are asked to find what x greater than or equal to 21. So we know that 21 will be somewhere here. So 21 will be somewhere here. But then since it's not exact figures, okay, it's not easy to find this using the empirical rule. That one I'll not go there. That's why we use the probability table. Sometimes the figures we get, we are not able to use the normal calculations to solve them. That's where the table comes in. So the 21 will be somewhere here. And they're asking us to find probability that x is greater than 21. So this side is what? Less than. If 21 is here, then to its left is less than, and then all this side will be what? Greater than, right? All this side will be greater than. So first, since we've understood that we have to use the probability table, we can't use our head to find the answer. Then we'll find our z value, because we don't have 21 on the probability table. So we use our z value to find an equivalent for our table. So the z will be the x as a figure minus the mean, all divided by the standard deviation. So our z is equal to, our x is 21 minus our u is 30, all divided by our standard deviation, which is 4. So our z is, use your calculator to get your answer. So 21 minus 30 all out of 4. So we get negative 2.5. So that is the answer we got, negative 2.5. But then, just because we got negative 2.5 doesn't mean we should just rush to the negative table and then we'll just get our answer. But it's based on the sign in the question. So here it says greater than or equal to. So we are looking for figures within this side, right? So first we can use the negative table to find here. So we know that probability, the sums of probability is equal to 1. So all this side, all the probabilities here, plus the probability in this small circle should be equal to 1, right? So that should be this one. And then we know that to the left of 21, all these figures, they are in the negative table. So let's look at the negative table. So this is the negative table, you see. So if we were asked to find x less than 21, it means all figures within this range. So whatever figure you pick from the negative table, that will be your answer. But here we are asked to find what? X greater than 21. I mean, figures within this range. You get it? And then the negative table is for only this range. So because we know probability sum up to 1, when we find our answer, which is within this range, and we subtract from 1, we can get all the probabilities for this range, which is what we are looking for. So for here, we know that it's negative 2.5. So we just add the 0 here. Then we the negative 2.5 from the negative table. So you move to negative 2.5, which is here. And then we'll look for our 0.00, which is this one. So this is the answer we'll pick here for the negative side, that's less than 21. So which is 0.00621. So this answer. This answer is for this side, which is what we read from the negative table. But then be careful that we're asked to find this side, not this side. So if we have been able to find this side, it means that we can what find this side by subtracting this figure from 1. All right. So our answer will be 1 minus 0.00621, which will give us 0. Okay, so there's a mistake somewhere. You see, this one is supposed to be negative 2.25. So my calculator made a mistake. So this side is negative 2.25. Okay, sorry, not 2.5. So we go back to our negative table to read negative 2.2 at the left hand side. Then we'll look for 0.5 at the right hand side. So in the reading, you read the first two figures and read the last figure, which is 0.5. 0.05. So the 0.05, that's be the last figure we read. So first we read the 2.2, read the negative 2.2, which is here. Then we read the 0.05. So here's 0.00, 0.01, 0.02, 0.03, 0.05, 0.05, which is 0.01222. So 0.01222. And that is not our answer. This answer is for this negative side. But then we are asked to find this positive side. So we subtract 1, this figure from 1. Okay. So here 1 minus this figure. So you also calculate with your own so that you can move on the same place. So 0.98778. Right? So this will be our answer, 0.987. So that will be the probability that x is greater than 21. So that's the importance of drawing the probability curve. You get it? That's the importance of drawing the probability curve. Because if you don't draw and you just take the 21, find it from the negative table, you get answer wrong. But you don't know the direction that they are asking you to look for. So you have to draw the table, right? So someone can say, instead of going through all this hurdle, I know that they said I should find 21. And then the 21 is is in the right hand side. So the left hand side negative table. And then my answer is supposed to be at the positive side as greater than. So I can just go straight to the positive table and pick my answer. Though the figure here was negative 25, but the question said greater than 21. So it means I'm looking for a figure in the positive side. So I'll just look for 2.25 in the positive table. So let's try it and see. Let's go to the positive table. Go to 2.2. They will look for the 0.05. So this is 0.00, 0.01, 0.02, 0.03, 0.40. So if you find out that there's at the 2.25, yes, our answer is what? 0.98778, which is the same as subtracting the negative answer from 1. So it's just about you understanding the direction you are going to. Then you'll be able to find your answer. So let's look at another scenario or another question then. Let's see what happens next. So our next question is find what P30. Probability that x is greater than 30 but less than 35. So first of all, if someone sees the person will be confused. So first draw the curve and see how it looks like. You get it? Just see how it looks like. So it said x is greater than 30 but less than 35. Okay, so if that is the case, Then let me use a different. So sorry, I want to write it down. So the probability that x is was greater than 35, but 30 but less than 35. So that's what we are asked to find. Right, that's the probability. So first let's draw the curve. But we know that our mean is what? 30. And our standard deviation is what? 4. So I'm coming to draw the curve to know how this would look like, right? So we know this, and we have a, sorry for the drawing, and then we have the mean, which is what? 30. And we are told to find x, which is between 30 and 35. So you know that 35 will be somewhere here, because from our standard deviation, for using the standard deviation, the next figure is supposed to be what? 34. Then the next one will be what? 38. All right. So that's how the standard deviation works. Just add 4 to the next figures. So there's 3, just add 3 to the next figures after the mean. Then you subtract 3 from the mean up, or 4 from the mean up below the mean. So for this side, it will be what? 26. Then the next figure is subtract 4, and then you go on and on. But here we are looking for x, which is between this 30 and then this 35. So the area within this side, right? So when you get questions like this, where you are supposed to find for x within certain values, the easier way, or the easiest way to do it is that you need to find the z for this, the extremes, okay? So the z for this 35 and the z for this 30, right? Then you translate it. So now, because we're using the normal distribution table, here will no longer be x, but instead will be what? Our z. So let's find the z for 30 and the z for 35, because that is the range you are looking for, right? So the z for 30 will be, so z equal to, you know the formula by now, so we'll just go straight forward. Our value, which is 30, minus our mean divided by our standard deviation. 30 minus so here is also 30. 30 minus 30 is 0, divided by 4 is 0. So we know that this will give us 0. Then the z for the 35 will be 35 minus our mean, which is 30, divided by what? 4. And then this will give us, use your calculator, 35 minus 30 divided by 4, give us 1.25, right? 1.25. So now we translate this figures into a form like this. So now we get, so our focus now on the table is to find the probability that what? Z is greater than 0, but it's less than what? 1.25. So whenever you are writing, let's say intervals, the smallest figure will always come here, then the bigger figure will come here, right? So after you are done, so this is what you are looking for. And what does this mean? It's telling us that you find, so this in other words means that the probability for this is equal to the probability, that's using the table, of z, right, less than 1.25. So always the bigger figure will come first, right? Minus the probability that z is what? Less than 0. So the bigger figure, the probability of the bigger figure minus the probability of the smaller figure. So that's where I come to use the table. So you find the probability for this from the table, the probability for this from the table, right? So 1.25 is positive. So with this, with the intervals is usually straightforward, and that's the simplest, because you don't need to look for the one at the left or the right. Since it's the middle, you just look for the figures. If it's from the positive table, go to the positive table, look for it and write it down, subtract, then go straight for it. But for those that they are just single, like x greater than 1, x less than 5, those figures, you have to be very careful. Know where the direction is. Okay, so this 1.25. We'll go to our positive table. Okay, it's 1.25. So we'll look for 1.2 here, then we'll go and look for our 0 point or our 0.05. So 1.2 is here, then our 0.05 is here. So our figure here is 0.89435. 89435. 89435. 89435. Minus the probability for that x is less than 0. Okay, so 0. So we go to our table, look for 0. So 0.0000. 0.0. Then its remainder is 0.00. So the figure is 0.50000. So we'll come here and write minus 0.50000. Then our answer will be our answer will be our answer will be 0.3999435. So that will be our answer. You get it? So for the um, so for the middle ones, they are usually the easiest. Okay, just have to find probability for the bigger figure minus the probability for the smaller figure. We have to first translate the figures towards to the z aspect because we're using the table. So you can't find 30 on the table, you can find 0 and 1.25. When you are done, you subtract and you get this figure. I hope that one is clear. All right, so with the probability table, you just have to know where the curve is going, right? Which direction is the curve, or which direction is the question asking me to move in? Okay, and then if you are given the negative table, but then your answer is positive, just use the negative table. Just ignore the negative sign, then look for the answers. When you are done, subtract from 1, you get your answer. But you have to make sure that the sign in the question is corresponding to your answer. So based on the question, you know whether, oh, okay, so though it's the negative table, the answer is supposed to be in the positive table, or the answer is supposed to remain in the negative table. Okay, so I don't want it to be very long, a long video to make it boring, so I want to end here. But then if you want me to, there are more questions. You see, there are more questions, but I can't do all in one video. Else you get bored and tired. I'm even tired already. You get it? So if you want me to do like more on other questions, just let me know in the comment section. And those who know my WhatsApp number, you can WhatsApp me. I'll help you out. So I just hope this video is helpful, and I have to make sure that first translate the figures into the z value, the z value. Draw your table and know your direction. If the figures are is between 2 points like this question, then you just know you have to find or change them into this side by finding the z for the extremes. Then you just find their values from the positive and negative table and subtract. Simple. But then if it's just only one value, like probability of s greater than 70, and you have to be careful where the sign is pointing. So your answer might be negative, or your answer might be positive, but the sign will determine where your answer should be. So just take your time, watch the video, do more examples, and I'm sure that the Holy Spirit will help you. Enjoy your day, and please kindly share, subscribe, and click on the notification bell. God will surely bless you. Another time, meet each other. Bye bye.